Hello everyone, my name is Andrey. Today we continue learning Python, and today we'll talk about the biggest problem with Crud APIs. So let's start. Not only APIs but the programs in general, and what is Crud, first of all. So Crud, create, read, update, delete, is I think the most popular architecture right now, because basically what you can do with your application, with your state, so with a database, with your data, is you can either read your data, update your data, delete your data, or create your data. So Crud. Create, read, update, delete. And basically what happens when we have some kind of an application. I'm going to talk about web APIs, but it can be any sort of app that follows Crud. So we have an actor, so our user, which sends something like a request like create a user, then our application says, all right, no problem. And our application just goes to the current state. It can be NoSQL database, SQL database, so any data storage, persistent data storage. And our application basically executes some queries. In terms of SQL, the most popular architecture is when actor says, let's stick with the create user, actor says, create my user. Application says, no problem, and it just executes insert on our database. However, what is the problem with that architecture? The problem is in that word current. So current is the worst thing about REST. Because if our actor says, create my user, application says, no problem, I'm going to create him or her, and creates a new record in our database. If our actor says, update my user, our application will update the information about our user. If our actor says, delete my user, our application will delete that record. And the problem is that we don't have any history of what happened. How did it happen? When did it happen? What was the order of our queries? And we can't really go back to 5 queries before our current state. We can't really go back to the beginning of our application. We only have our current state. And by that I mean like we only have the result of all of the queries that we executed on our database right now, but we don't know all of the queries that we executed. We don't know all of the states that our database was in before. And why is that a problem? The first thing is that data is really, really important in modern world. So if you have data, you can build neural networks, you can analyze the data, you can prevent some serious problems with your queries, you can almost do whatever you want. So data is money. Data is very, very useful. And in terms of Crud, we only have the current data. So we don't have any data that was before that. We don't have any history of our queries, of our states. And because of that, we can't really do anything with our data because we lost it. We only have the current data and it's not enough. So if you want to build a neural network that will analyze your clients and you only have your current state, then that's really, really bad. But if you want to build a neural network and you have the history of all of your queries for the last 10 years, then you're going to have lots of data and it's going to be really, really easy for you, in terms of data, of course, to build that application. So data is very important. That's the first idea. The second idea is that, well, continuing with the data, which is important. Imagine that we have a crypto exchange. So right now I'm writing my own crypto exchange. And what if I would choose Crud as our architecture? So what would happen? Imagine that we have a thief that stole, 10,000 Ethereum from Ethereum network. Then he deposits that money to our current state. And then what he does? So our thief deposited the money to the first account, then he sends the money to the second account, then he sends the money to the third account, and so on. So second, third. Once again, someone stole money from Ethereum network or from any other cryptocurrency network. Then he deposited that money to our application, our crypto exchange. Then he sent that money from the first account to the second account, to the third account on that crypto exchange. So we basically created a trace for himself. Now we can't trace him. However, then he says, why do I need to leave that trace? I will delete the first account, I'll delete my second account, and I only have my third account. And right now, if our user executed all of those queries in Crud, once again, we don't have any state that was before. We don't have any accounts that weren't deleted because of his actions. So he deleted all his accounts and now we only have the third account, and it's going to be impossible for us to really trace the money, to really trace what happened. So yeah, data is really important. Another example is with banks. So when we work in a bank, if we have just like a balance So imagine you have your account and you have balance 100. When you deposit your money, you say that your balance is $120, for example. What is the problem with that? The problem is that, first of all of the accountants do not work with just numbers, they have ledgers. So ledger is kind of like a system of credit and debit. And it's kind of like a history of all the operations. You don't have like a number, balance equals to something. However, if our bank uses Crud, then what do we have here? Balance 120, and imagine that we have a call from our client. That's the balance of that client, and he says, I'm sorry, my balance should be 100,000. We're saying, wait, let us check. We're going to our database and you only see balance 120. Of course, we can have the history of our operations and all that stuff, but still, there's a history of our operations. However, here, balance 120. If you only have that, if we only have our current state with our balance as $120, then we can't really tell the client if he's right or wrong. What if he's telling the truth and we have a bug in our system? So we somehow removed 90% of his balance. So he had 100,000 and we only have 120 in the database right now. What if he's lying? And we can't really check both of those cases because we only have our current state. And that's the biggest problem with Crud. Of course, the biggest plus with Crud is that it's really easy to build those applications. So what you basically need to do is learn how to deal with databases, learn how to deal with some kind of API, some kind of that connection between your client and your application, and then you just basically need to build your normal application, secure everything and all that stuff. It's relatively easy. However, we have a better thing for very complicated projects that really need to save the data, and it's called event sourcing. So here it is. I don't know, how can I, like that. Here it is. That idea is called event sourcing. So it's another architecture that is widely used nowadays. And what's the difference? So here, don't look at ReadModels here, but we have a database, we have our actor, and we have our app. So both of those are apps, so ReadModels and app, but for now we're only looking at that. And before you look into that architecture, I highly suggest you watching my previous video, which is called CQRS, or Most Useful Pattern in Microservices. And CQRS basically means that we split commands and queries. Command is something that returns nothing but changes our state, and the query is a query that returns something but does not change our state. So we change the data in the command, return void or none in Python, and we do not change any data and return the thing that we queried in queries. Alright, so that's how it works. Let's look at event sourcing and what's the difference. So our actor sends a request to our command, and let's talk about our bank. So the first thing that we need to do is create our account. When our actor says, application, please create my account, application says, no problem, and application sends an event which goes to our database. So that's basically a database which contains events. What's the difference? Instead of just executing create or insert in the case of SQL, we're gonna say, application, please send an event, create user, or create account, whatever you like. Our application sends that event to our database, and there we're gonna have create user with all the information that we need. So our username, our ID, our password, every information that we need for our, so basically like our SQL query, we're gonna store that. Not the SQL query, but all the information that we need in order to execute it. So for now, let's just create user with username admin and ID 1. So here we have our event. Very basic. That event is not like a data that we can query because it's just an event. It contains all the data, it contains like what happened, not what's the current state, but what happened with our application. Alright, then our actor wants to deposit some money to our bank. He says, please deposit my money from, I don't know how, deposit my money from crypto, from cash, from another account, and our application sends another event called deposit money. It can be stored in a separate table, it can be stored in a separate, somewhere separately, but for simplicity, I'm going to store that in the same chain. So our actor sends an event called deposit money to our application, to our database, so forth. And we have deposit money event here. And that deposit money event contains all the information that we need. So the account of our user, like how much money, message for that money, so all the information that we need in order to deposit our money. And I'm just gonna write deposit 100, so deposit $100. And as you can see, what I'm doing here, instead of just applying all of the changes as they come to our application and to our database, I create a history of all the changes. So all of the changes are not applied yet. But what we can do is we can apply all of those events in order to get the current state of our application. Or if we have some other events, like our user wants to retrieve his money, retrieve money, for example 50, then I don't know that, deposit money once again, deposit money 10. What we can do here is create a history of all the operations, and we can go from the first one to the last one. All of those have a unique identifier, like an ID in a database, and they go from the first to the second to the third to the fourth, and we basically build a chain of events. Or a lot of people know a very, very popular technology nowadays, which is called blockchain. And basically those event sourcing patterns and blockchain are very similar in terms of the idea that we have an immutable data storage, and each block in terms of blockchain and each event in terms of event sourcing are related one to another. And yeah, so we can't really have create user after all of those events, because created user was the initial genesis event that was in our application. So that's the most important thing, that we have events that are related to each other in a very strong sequence. Also, what we have here is the idea that we can delete events, because if I delete create user, then who deposited that money, who retrieved that money, who deposited that money again? So we don't have our account. So each event is very, very important, because if we delete one event, well, depends on the event, but if we delete one event, the whole chain may break, and you're gonna have lots of problems in your application. So never delete your events. Instead of that, if you want to delete your account, what you can do is, instead of just deleting all those events, you can create a new event called delete account from ID, for example. And what's the biggest or the coolest thing about those events? The coolest thing is that we can get any state that we wish. So we can say, all right, what was the state of our application after the first 5 queries? 1, 2, 3, 4, 5. No, let's say after the first 3 queries. 1, 2, 3, we apply those 3 events, and we have our state in our database. That's really, really cool. So we can get any state, and we have our history. So if I want to get my data for the last 10 years, I can do that with events. Very, very simple. And we store those events in a database, in a separate event store, wherever you like, typically in a database. All right, so that's how it works. However, you may say, all right, but our users, they do not care how we store our data. They do not care what's the architecture that we're using. The only thing that our users care about is that the program is working, and all the other things, like the program is great, the program has lots of features, but we don't talk about that. The only thing that we need to supply to our users here is that our program is working and our program works fast. However, how can we get the last state of our application if we have those events? Well, you can say we can apply all of those events, so create user, deposit money, retrieve money, deposit, delete account, and all that stuff. However, if we do that and we have like 10 million events or 20 million events, then it's going to take a lot of time. And if we have 10 million events, should we like rerun all of those events on each request from our user? The answer is, of course, no, because there are tons of techniques in order for us to get rid of that. So get rid of all the events that need to be reapplied in order to get the last state. And the most popular technique, and the technique that works and that should be used in every application where you have event sourcing, is called ReadModels. So here we have 2 applications. It can be one application, those can be applications on different servers, it can be anything. So in our case, we have 2 different applications. So server 1 and server 2. But once again, it can be the same process even. But typically those are different because we need to scale reads separately from writes. And once again, query is read, command is write. Watch CQRS if you don't understand what I mean. And what do we do in ReadModels? ReadModels is basically the latest state of our application. So here in database we have events and ReadModels, which is current state. Basically, ReadModel is your Crud. So how are we gonna derive the current state from all of those events? We're basically gonna apply all of those events. So create user admin 1. We're gonna create our user. So user admin 1 admin. So ID and the username. Then we're gonna deposit money. So another table or the same table. I don't know how your data schema is managed. What's your data schema? But imagine that we have another table for all of the deposits of our users. Deposit money 100. So we're gonna say balance of the user is 100. Then retrieve money 50. Balance of the user is 100 minus 50, 50. Then deposit money 10. Balance is 60. And then delete account. Yeah, we're gonna delete account, but for now let's just leave it as it is. I'm gonna remove that event. We don't do that, but I'm just gonna remove it to show you how that works with ReadModels. So we have two things, events and ReadModels. ReadModels should not be changed directly. They are only changed when events change. So what we can do is if our command, so if the event is invoked, then we can add that event to our event store, and after that we can change the data in our ReadModels according to that event. Alright, so that's how it works. Then, how our actor is going to retrieve that state? He is going to go to ReadModels. Yeah, so he's going to create a request, send a request to the ReadModels, and our ReadModels are going to be just like rest things in our database. So ReadModel is basically the current state, and you can easily read it, but never write it. Yeah, write your ReadModels yourself. So they only need to be changed whenever something changes in the event store. That's really important because they're even called ReadModels. Because if you change something in your ReadModels without changing your events, then you're going to have inconsistencies, and we don't want that. Alright, so events change ReadModels. ReadModels do not change any data by themselves. And our actor goes to ReadModels, and ReadModels basically retrieve that information. And because we have our events, our history, and we have our ReadModels, our current state, we can store a lot of data, we can analyze the data, we can basically do whatever we want. And that's a very great architecture for your next project. And I'm gonna use it in my FinDev, so in my financial exchange project that I'm writing right now. And I think that's it for now. The only problem with that architecture is that it can be really hard to write and maintain. But I'm gonna show you how I can do that, and that's kind of what it is. So thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment, write what you wanna do in the next video. If you have any questions, then you can ask them down in the comments, and bye bye.